Hello guys, how are you? So in today's session we are going to talk about simple linear regression. And simple linear regression is a machine learning algorithm where we gonna train our data to get some output, like when we have some data and we have to predict the output based on the one input, like you have a data for age and blood pressure. You have data, let's say for the age 10 you have blood pressure I don't know about blood pressure much, but let's say for the 10 age you have blood pressure 15 or 16, and for the age for 15 you have blood pressure like 30, and for 20 you have blood pressure like 32, 35. So based on the data you train a machine learning model, and when you just provide the age to that model, it will give you the blood pressure for that age. So something like that, we're gonna train our model based on this simple linear regression algorithm, which is very much used and very much known to the machine learning data engineers and deep learning engineers. So let's start it with this. And now, in statistics, simple linear regression is a linear regression model with a single explanatory variable. That is, it concerns two-dimensional space points with one independent variable and one dependent variable, and fields a linear function that as accurately as possible predicts the dependent variable values as a function of the independent variable. So here basically it wants to say that in simple linear regression we have two variables. One is dependent on the other variable, and like when you have two variables, one is independent, other is dependent on that independent variable. So when you just provide the independent variable, your model will gives you the value of that dependent variable. As you can see here below, we have on x-axis we have the independent variable, and on y-axis we have the dependent variable. So when we provide the value on the x-axis, like when we provide the value of 30, so according to this line we get a value around 9 in as the output, which is the dependent value on this independent variable. So that's all. This is how we this is like a simple linear regression, and OLS, ordinary least square. In simple linear regression we have a data, and we just have to find out the best fit line for this so that we can minimize the much loss as we can. Like this point is far from this line, and this point is also far from this line, so we have a loss value there. As you can see, we this line isn't get touched. So by seeing this, like when I provide a value of 29 for this, I should get a value of around 4 or 5 point something or 6. But according to this line I get a value something around 8 or 9. So this is our loss, like we don't get the correct value. We have a difference of 3 to 4 units or 3 to 4 points in this output, and thus we can say that we have some loss, and we have some loss also here. So according to this data we have to find out a line which is best fit for this data. And when we get our line, now then we gonna predict something like any when we then we provide a independent variable and get the value of dependent variable through this line. But how this line get fits, what is the criteria? So as you can see, by seeing this point, there is a term called as OLS, like how you can measure the distance from this point from this line. Like you can measure this point this you can measure the distance of this point from this line, like this is this is that much distance from here. You can take the perpendicular distance, you can take the distance, you can take the line which is perpendicular to the x-axis, and according to that line you find the distance between this point and this line. Also you can do this, according to this point you make a perpendicular line which is perpendicular to the y-axis, and from that line you find the distance between this point and this line. So OLS is a technique when you just drop a perpendicular from this point to the x-axis, and through that line you find out the distance you sorry. you find out the distance between the this point and the this line. So here comes the OLS. OLS is ordinary least square. OLS chooses the parameters for a linear function of a set of explanatory variables by the principle of least squares, minimizing the sum of squares of the differences between the observed dependent variable values of the variable being observed in the given dataset and those predicted by the linear function. So according to this data, as you can see that for these point we get this best fitted line. And how we can measure the distance between the point and this line, as you can see, we just draw a perpendicular from this point and the from this point to the x-axis, and extend that extend that perpendicular line. And when we get the intersection between that perpendicular line and the this best fitted line, we get our distance between point and the line. So here we have many points like 1, 2, 3, 4, 5, 6. We have 6 point, and we have this line y is equal to a plus bx, and we have to minimize the loss. How we can calculate the loss? This is our point. We get this predicted value, and by subtracting these two values and squaring them and summing all these distances, we get our loss, and we have to minimize that loss. So to find out the loss and to find out the distance, we just calculate the y coordinate of this and the y coordinate of this, and just by subtracting that, we get our loss function, loss value. So that's all about this ordinary least square OLS. And next comes the normal equation. You are is thinking that when we have these 6 points, when we have this 6 points data, how we can find out our best fitted line? We don't do calculation for each points, or we gonna make a loop for all of these points. So to get this line, we want two values, a and b. That means we want a intercept, and then we want a slope value for this line, and then we just make our model, and then we get this line. So to get the weights of this line, weights means the intercept and the slope value. Weights of this algorithm, weights of this model means intercept and the slope of the linear line. So here intercept is a and the slope is b, and to find out these weights, we just use this formula of this normal equation. We have the data x, and we transpose the data, multiply those two matrices, multiply those two matrices and inverse that, and again dot product with this. First we get, sorry, here we also do the dot product. Then after inversing the whole this matrix, we again dot product that matrix with the transpose of the input matrix, and then we again do the dot product with the output, which is the y matrix, or you can say y is the vector. And when we multiply this, we get a matrix of two values. When we do the dot product of these matrices, we get a matrix of two values. That means we have a matrix of two rows and a single column, and that two rows were employing the slope and the intercept of that line. So here theta is the weights for the line equation, which is best fit to the data according to the linear regression. Next comes the performance metrics. RMSE, root mean square, error uses Euclidean distance, and MAE, mean absolute error, uses Manhattan distance. So basically, as I told you, when we have to calculate the loss value between the when we have to calculate the loss value between the point and the line, we just subtract the y value, yi minus the y hat, and yi means the original value and y hat is the predicted value. So for this point data, for this x value, we have this y value, which is the original output, and y hat is this value which comes at this point for the y. So when we subtract yi minus y hat, squared, we squared them and we add all of these distances. We square this distance and add to all of these distances. So this is using the Euclidean distance, because we doing the square of distances. And if you don't doing the square of distances, then you are just using the Manhattan. If you are don't squaring the distances and subtracting the values, get the distance and add all of them, and by adding all of them, you are using the MAE matrix. And if you are using the square, then you are using RMSE matrix. So here this is all about RMSE and MAE performance matrix. RMSE is an acronym name for root mean square error. It is a cost function that measures the standard deviation of error a system makes in its prediction. So as I told you, when you get loss and you do square and you do calculation like doing square, you're using the Euclidean distance. And when you are using the Euclidean distance, you get the loss function. You get a loss function for that, and that loss function is called as root mean square error. And if you're don't doing the square, and if you are using the absolute value, then that loss function is called as MAE. MAE is a acronym for the mean absolute error. It is the cost function that measures the distance between observed values and the predicted values. So that's all about the metrics, performance matrices. And next comes RMSE is less preferable, because if there is any outlier present, then it will give loss value very high. And MAE is preferable. Like if you have a outlier in your data sets, then the distance between that outlier and your best fitted line is too high, and it will give you and it will give you a high loss. But and that time MAE, mean absolute error, is preferable. But while we are doing the data pre-processing, we remove the outliers. And when we remove the outliers and get our get our processed data, then we can use the RMSE. At that time RMSE is preferable.